Hey friends, if you're using Playwright for end-to-end testing or synthetic monitoring with Checkly, you've probably encountered the problem of flaky tests. And while many people blame the end-to-end tests for being flaky, the root cause is often in the environment or the site that you want to test. And when it comes to the front-end side, very often poor hydration patterns play a big role in flaky test results. What are they and how can you work around them with Playwright? Let's find out in this video. Let's look at an example to understand what poor hydration patterns are. I have a quick demo site here that greets us with Hello World, and it includes a sign-in button that when we click it, changes the page to show us this lovely raccoon and tells us that we are in. So how could we test this with Playwright? When I now head over to my editor, here we find a pretty standard Playwright test. It includes tests and expect. From Playwright tests, it already navigates to the URL that I just had open in the browser. Then it clicks the sign-in button and then it waits for an image that includes the alt text, a raccoon to be visible. And this looks pretty straightforward, doesn't it? But let's run it. When I now go to the terminal and I run npx playwright tests, we will find out that this test isn't working. And why is that? When we go back to the page and we try to click this button very quickly after the page has loaded, we will find out that it actually doesn't work. It takes a little bit until the JavaScript is loaded and the functionality is added to the page. So this is a poor hydration pattern. The UI looks functional, looks ready, but it is actually not, because we're waiting for the resources to be loaded. And this is one of these situations when Playwright is clicking the button just too fast. Because whenever you call a Playwright action such as click, Playwright will retry and wait for this element to be visible, stable, not moving. And then when this button is there and it looks ready, Playwright will click it. And this is such a common problem that when we head over to the Playwright docs, there's a whole section that deals with hydration. And here we have it black and white. At some point in time, you stumble upon a use case where Playwright performs an action, but nothing seemingly happens, right? This is exactly the case that we're dealing with. So how could you fix it? In an ideal world, as described here in the docs, the right fix would be to deliver and serve disabled elements. Because when you think of this, a user on slow network connections could also come across these elements that look functional and they're clicking on them and nothing is happening. This can happen to all the users out there all the time. And this is what I love about Playwright testing, because with Playwright you will notice these poor hydration patterns. So ideally you would now fix your tech stack and you would disable these controls when they're not ready yet. But unfortunately, this is not how the world works most of the time. Maybe the front-end code is owned by a different team. Maybe the front-end is served by this one legacy application that nobody wants to touch. There are multiple reasons why you can't fix this poor hydration pattern when you want to write your tests. But how could you make your tests more stable when dealing with these patterns? One approach would be to put in an artificial delay here right before the action of clicking this button. But this won't necessarily make your test case more stable, because you are now putting in a magic number. Let's say it will be 3 seconds. But if then the network is slower at this moment in time, the button will still be clicked too early. What I found to be a better strategy in these scenarios is to implement your own retry mechanism using Playwright's toPass method. When we now go into our test case, we can say await expect, and expect usually expects a number or locator in Playwright, but it also can handle a callback function. And when you pass in a callback, you can call toPass. And what now happens is that Playwright's toPath method will run this function here, this callback that I passed in over and over again until it's not throwing an exception and runs through smoothly. So when we now move in our action and our assertion, so clicking the button and waiting for the image to be visible, this will be run repeatedly until the raccoon image will be shown. And to not slow things down, I will decrease the timeout option here of our image assertion. So what happens now is we're clicking and then we're waiting for 500 milliseconds so that the raccoon image could show up. If it didn't, this expect call will throw and we will try it again. And then we will try it again until this works. Compared to the timeout approach, toPass allows us to rerun actions and assertions until our UI does what it is supposed to do. But how long does it retry these actions? When we head over to the Playwright docs, we will find out that it is highly configurable. You can define the intervals, so how quickly or how fast the callback should be run again. So it's defaulting to 100 milliseconds, then 250, then 500, and then a second. So if you want to have more time before the next retry, you can tweak it with the intervals property. And by default, the toPass method also doesn't have a timeout. So it will retry until the overall test reaches the maximum timeout. But if you want to have a shorter timeout, you can do that with the timeout option too. So when I'm testing these applications that have this tiny time window, when the UI looks active but actually isn't functional, I found toPass to be a lovely little helper to get my tests more stable. So the only thing missing now is to go back to the terminal and go for npx playwright test. And here is a pro tip. If you want to check if your tests are really not flaky, you can call the test flag with the repeat each argument. And let's say we want to run our tests 15 times in a row. Let's kick this one off. And here we go. This now looks like a stable end-to-end test to me. But before you go all in with the toPass Playwright method now, remember that it would be a better approach to fix these poor hydration patterns into your front-end application. And this was this week's Playwright tip here on the Jackly YouTube channel. If you have questions, comments, or tips and tricks on how to make your end-to-end tests more stable, drop them below. And I will be back next week with the next video on synthetic monitoring, API testing, end-to-end testing, and anything that will help you to ship highly available and good stuff on the web. I will talk to you next week.